Welcome, Algebra 2 students. We're in Lesson 80. We're going to talk about direct variation as a ratio instead of a formula. So we know the standard formula for direct variation. If we were to say x varies directly to y, we would use a k constant times y, x equals k times y. And this constant represents to us the it's like a scale factor, right? It's the individual unit price or the quantity per. It's a factor. It's literally what it is. It's a factor. And then we reuse that whenever we're given a secondary event that happens, like if A, it varies directly to B, how much is A if B is this? Well, then if B is this a second time, a different cost, then what is A? So that we get an event to set our constant to figure out what this factor is, and then another event in which we apply that factor and we multiply it back out. All right, so let me give you a scenario in which we do that. Here's our first one. So here's our scenario. A varies directly as B. If A is 50, when B is 5, what is A when B is 7? So we write our statement, A varies directly as B. If A is 50, when B is 5, what is A when B is 7? All right, and we don't know what the constant will be that we fill in here. So first we have to find the constant. This should have been 5. We have to find the constant for k. So we have k times 5 is 50, so we divide both sides by 5. We find that the value of k is 10. So then we take our constant and sub it in for where our k would normally be. So we know that a is equal to 70 when b is 7. We can also set this up as a proportion. So let me move this over out of the way and show you how that proportion statement works. We will get the same exact answer. We just won't have to use a constant k when we set it up as a proportion. And the only thing that we have to remember is that we have to keep like things together in the same row and the same column. What I mean by that is we want to keep all of type A in the same column on the same side of the equation and all of type B on the other side of the equation. Then we keep event 1 on the same row of the equation and event 2 on the same row. And it doesn't matter what we call 1 or 2 as long as they are on the same row, it'll work out. Let me show you what that looks like. So if A is 50 when B is 5, that's the first event. When A is 50 when B is 5. So those are paired together as our first event. So A1 and B1. What is A when B is 7? That's our second event. So instead of a question mark, we use the variable x, and then we cross multiply. X times 5 is 5x, and 50 times 7 is 350. We divide both sides by 5. And we find that x is 70, which is the same thing we got the first time. There's just fewer steps. So setting it up as a proportion might be more advantageous for you. The only thing you have to remember, again, is the setup. You keep the same event on the same row and the same characteristic or identity on the same column. And it doesn't matter how you set it up, you're going to get the same answer. So for instance, if I put B on this side and A on this side, and I put event 2 on top and event 1 on the bottom, such that this would be 7 over 5 equals x over 50, it would still be the same information. This would still be 350 equals 5x, so it would still be 70 is equal to x. I could even just leave the events in the same order. So if I had B over here and A over here, and I left 1 over 2 and said 5 over 7 equals 50 over x, I still get the same setup. I still get 5x is equal to 350, which still gives me that x is 70. So what matters, as you can see, is the events have to go together and the identities have to go together. And as long as you have those in that format, then you will be fine. Okay, and on top of that, you could even put your events in different fractions and your identities in different rows. So if you rearranged it and you said A was on top and you said A1 is 50, we don't know what A2 is, and B1 was 5 and B2 was 7, you would still get the same thing. You would still get that 350 is equal to 5x, and you would still end up with 70. So it's all about keeping these same things together. Keep your identities together, keep your events together, and it will end up being the correct answer. All right, so all these scenarios show you that the proportionality statement is going to be a little bit faster than trying to solve for the constant k and then having to create a separate formula to solve for the second event. It's whichever one you prefer, though, whichever one speaks to your mind and is easier for you to wrap your head around, that's the one that you should use. So let's look at 80.2. We have another example problem here. Let me clear the page. All right, our second example problem says that cost varies directly as the number purchased. All right, so cost varies directly as the number purchased. So if 12 can be purchased for 78, this is the first event. So we're going to put the first event on the first line. So 12 can be purchased for $78. Let me set up my proportion. Then how much will 42 cost? So this is cost and this is quantity. So 42 is a quantity. So we're going to put that as our second event under this quantity side. We don't know how much that's going to be. That's going to be x. So now we cross multiply. 12 times x is 12x. And 42 times 78 is a number that I can't exactly figure out. 42 times 78 is 3276. All right, 3276. Now we're going to divide by 12, 273. So x is $273. So if we have 12, it costs 78. And if we have 42, it costs 273. And that is using the proportion statement to solve that. Now I will say this, using the other statement, the cost of 78 varies directly as the number purchased. This is going to tell us how much each one costs. And if we do the math, 78 divided by 12 tells us that each one individually costs $6.50. So if you need to know how much each individual thing costs, then your constant k is going to give you that information. You will not get that from the proportion statement, but the proportion statement is faster in that you don't have to figure out what each thing costs. You just have to figure out what the group costs, and you can do that in one fell step. Whereas this, you find out what each individual thing costs, and then you multiply again times 42, so it's a two-step problem. All right, let's move on and talk about the inverse variation as a ratio. So let me clear this. If I can find my little thing here. There it goes. All right, so if A varies inversely, so we've been doing direct variation, now we're doing inverse variation. So if A varies inversely to B, and normally we would write that like that. This is the following equation right here that is implied. But we can also use an inverted ratio statement, where before I used the ratio A1 over A2 equals B1 over B2, where the same event or the same characteristic was in a square shape to one another, right? So you had the same thing here and the same thing here, right? Inverse variation means you're going to flip it. So if you have A1 here and A2 here, then you're going to put B2 here and B1 here. So they're going to be swapped. Those events are going to be swapped. That's what the inverse proportion statement is all about. So let's work one of those, okay? And let me clear the page so we can see that. Excuse me. So here is our scenario. Blues vary inversely as yellows squared. Okay, so normally we would write that as blues vary inversely as yellows squared. That would be our original formula to use. But we're going to do this with the proportionality statement. If blues go with 100, if 100 blues go with 2 yellows, how many blues go with 10 yellows? So this implies two relationships here. We have, of course, the original statement, B equals K over Y squared. But we could also say, given this, that B1 over B2, that's the first event of blue, second event of blue, equals Y squared event 2 over Y squared event 1. All right. So we are going to fill in the information that we have. So on our first event, that would be B1 across from Y1, we would have 100 blues equals whatever the second event is, which is 10 yellows squared. The first event is 2 yellows squared. We don't know what the second event of blue is because that's what it's asking. How many blues go with 10 yellows? So the events, the information in the events go across from each other, not next to each other. All right. So that's what we have to remember. So 10 times 2 squared. So that's going to be 4 times, not 10, 100. 100 times 4 would be 400. And x times 10 squared would be 100x. We divide both sides by 100. We find that 4 is equal to x, right? So that should be our value for B. 4 is equal to x. So that was pretty straightforward and fairly easy to figure out with that. Let's double check it against this method and see if we get the same answer. So blues, the original event was 100 equals K over 2 yellows squared. 2 squared is 4. So that tells me that if I multiply this times 4 and this times 4, 400 is equal to K. That's our constant. So my second blue is equal to 400 over 10 squared, which would be 100. So my second event of blue would indeed be 4. But it took me only 1, 2, 3 steps as opposed to 1, 2, 3, 4 steps with the old way of doing it. So the main thing to remember is when it says varies inversely, that your events are going to be opposite one another So this y, this event 1 goes with this event 1, and this event 2 goes with this event 2, but you keep the same thing on the same side. Okay? You're just swapping the event of when it occurs so that you can cross multiply the events times each other, or the same thing in the same event is cross multiplied. You could even do B2 over B1 as long as you did Y1 over Y2, because then the same event would be across from each other and the same thing would be on the same side. And that's your structure for that. All right. And that is all we have for lesson 80. Guess what? You guys are 2/3 the way through the book. You only have 20, is it 23? I think it's 29 more lessons. Let me check. Yes, 29 more lessons. And we always know that the last 4 or 5 lessons are not super hard. So you really have about 24 really good lessons left, and you're going to be done. I'm sorry, I did my math wrong. 44. So that's about 10 more weeks of lessons, and then we're done. So, hey, we're rocking and rolling. We're going to knock it out pretty quick. I'll see you guys in lesson 81.